audible.
And
Yes, sir.
Yes, sir.
and my presentation is visible to all.
Yes, sir. It is visible.
Okay,
Yes, sir.
thank you, everybody, sir. So I know all of you are the teachers. So my get regards to all the teachers first, and that before starting this topic, machine learning, that I want to ask the question to myself as well as to yourself also, that why we learn machine learning. And before that, I want to ask question that why you studied during these 4 days, 3.5 days, that why you studied the artificial intelligence. What is the benefit of that artificial intelligence, or what is the importance of artificial intelligence nowadays? That's why you people are also means interested to attend this workshop, and I hope you have already know many things. And you can also enjoy this session also. So then the first thing is why we will study artificial intelligence nowadays. So then before that, I want to ask again the question that what is the reason? So then because already we have happy with our conventional system, conventional machines, that is computer, then why we use the artificial intelligence for getting means what benefit actually, that we'll discuss. So then first thing is that can all the real world problem, that means I want to say one thing, that in this universe, so then all the living beings, including human being, animals, all the living beings, even tree also, so all they are means involved in solving problems in every day. So can yes, can the real world problem to translate to mathematical problem? So then, if it can be translated to mathematical problem, then it is fine that we can solve the many means operation by using the computer. But the all the problems can be solved by the mathematical problems, means can be translated to mathematical problems. That means, suppose my question is how to become a topper, how to become a topper in a class. So is there any, for this problem, what is the solution? Is there any means can we translate any problem to its mathematical form? Then we can write the algorithm, then can our computer can process and tell us the decision or tell us the result. Okay, so then any problem if you want to solve using a computer, so then we have to translate, or we have to means make an algorithm of that problem, then we'll execute by using some programming language. Already you have studied the Python programming language, then by which you will execute the program and you will get the result. So then that is the decision. Okay, so then that means no, my question is that all the real world problem cannot be solved because that we cannot transform easily the problem to its mathematical form, or we cannot make the algorithm, then we cannot we cannot write the program and we cannot get the output. That's why means we cannot solve the problems. Okay, all the problems we cannot solve mathematically. Then next thing is what? Can all mathematical problems solved by the computer? No, because even though we have some mathematical means fundamental things, then
Sarangi
hello,
sir, 1 minute.
sir.
Sir, there is some thing which is hiding your PPT, some square box at the right side of your PPT.
Okay, then how to remove that, sir?
Is there any window opened over the PPT?
Yes. Okay, sir. Okay, sir. Yes. So. Actually, I cannot remove that. Yes, it is fine. Okay,
Yes, sir.
okay, sir. Thank you. So then next thing is all the problem, even though it mathematically it can be expressed, but we cannot solve because of that problems are called halting problems. Okay, so then halting problem means the programs will recursively run and we cannot solve it by the computer. So then can all solvable problems can be solved in polynomial time or reasonable in less time. That means whatever the problems are solvable by the computer. So some problems which are solved in a very fraction of time, that is in polynomial time. In computer language, we are telling in polynomial time. But some problems are there which cannot be solved in a less time. So it takes a very large number of means we can say the number of days or number of months or like that. So then that is exponential time. So that is not can be solvable. So then this type of that's why all the solvable problems cannot be executed in polynomial time. So then that there is a problem that is called the traveling salesman problem. Okay. So the next part is, so then what to do if the problem is not solvable? Okay, what to do if the problem is not solvable? The first I told that it is not possible to formulate a mathematical model for the problem by which that's why we cannot write the algorithm and we cannot solve in a conventional way. That is the one problem. Second, even if it is solvable, there is an algorithm, but it takes a very huge time. So then we cannot solve it in a less time. That's why it is also a problem. So then to settle for solution of means again the next thing is the if the accuracy is also not good, suppose, then what to do? Next thing is what to do. So the thing is, but then next the main thing coming right now is the artificial intelligence. Yeah. My voice is audible to all? Yes. Hello,
Yes, sir.
sir.
Yes,
Yes.
sir.
Yes, sir. Yes.
Okay.
Audible.
Yes,
Yes,
sir.
sir. Thank you. Thank you. Thank you, madam. Thank you. Thank you. So then, means the means uh, why it is echo? Voice is echo. Hello. Okay, so then how to solve that problem for which we cannot write the algorithm? So then in that time, the concept of artificial intelligence came to the picture. Okay, that means the artificial intelligence mimic the nature intelligence. That means how the living beings in this world are solving their problems in day-to-day life. So then that mimicking process, if you will follow in our algorithm, in algorithmic form, then our machine will be intelligent and it can be behave like the human being, the way human beings solve the problems. So then keep attempt to reduce accuracy by involving the models by mimicking the natures. So then I told that the problem which cannot be solved by some algorithms, by the conventional algorithms. So, or the problem is solvable problem by the conventional algorithm, but the problem is it takes lots of time. So then to avoid that, so then we generally use the artificial intelligence. That is the objective of artificial intelligence is. The next part is, yes. Then it is the science, what is artificial definition? It is the science and engineering of making intelligent machines. Okay. The main objective of artificial intelligence is to make intelligent machine which can solve the problems that cannot be solved by the conventional algorithms, or if it is solvable, then it takes lots of time. To avoid that, we generally use the artificial intelligence. First thing. And second thing, means the AI doesn't confine to itself to the methods that are biologically observable. So then the person is John McCarthy from IBM. So it discussed, it defined the means artificial intelligence like this way, and he is the first person coined the term artificial intelligence. Okay, the word artificial intelligence comprises two terms, that is artificial and intelligence. So artificial refers to that the something which is developed by the human being. Okay, so that is nothing but the machine. The intelligence, again, what is intelligence? Intelligence is the computational part of the ability to achieve the goals in the world. in simple way, what is intelligence? Intelligence means the ability to solve the problem. Okay, ability to achieve the goal. So that is nothing about the intelligence. So then varying kinds of and degrees of intelligence occur in people, animals, and some machines. Okay, so AI is a belief that the brain is a form of a biological computer and the mind is computational unit. So then artificial intelligence is not confined to only computer science. Then it also means connected with the other disciplines like a cognitive science. And a cognitive science means what we can say, it is interdisciplinary science, and it performs operations of intelligence as well as the behavior of the human being. Okay, it analyzes the behavior of the human being also. Then philosophy, then psychology, then linguistic, the natural language processing. That means by using the artificial intelligence, we can develop the natural language processing (NLP) softwares, and by which we can translate our means classical language to any other language of different form. So then everybody can understand that is nothing but the NLP. So the neuroscience is there. That means all they are combined. They form the the AI area. So then I want to discuss little bit about the AI. I think you know this. Still, I want to discuss it because this is also important. You should know all the history of AI. So then it started actually the mid of 20th century. In 1943, the first person, that is Warren McCulloch and Walter Pitt, introduced the first neural network model. Okay, so then this is the, we can say, the beginning of the artificial intelligence era. Okay, so in 1950, the main person of artificial intelligence, we can say that Alan Turing, so argued to a question that can machine think? If we can incorporate thinking part to the machine, then machine can analyze the data and means take the decision intelligently like human being. So is it possible? So from that 1950, the Turing machine asked this question. So then just imagine how intelligent they are in that era. Right now, I think it is more than means 70 or 80 years. So then also, then we are now beginning with this course, but they have already told the same thing in 1950. In 1955, Oliver Selfried proposed the use of computer for pattern recognition. So then pattern recognition means what? So then suppose like we are recognizing the object like at the child age. So we are recognizing the objects like that is apple, that is banana, then different types of objects, that is mommy, that is papa, so all these things. So then similarly, if the computer can also recognize the different object, then this area is called pattern recognition. That means we can recognize the pattern. So then that was the when first started with in 1955. In 1956, then John McCarthy from IBM, I told that the first person, he coined the name of artificial intelligence in 1956. So then after that, the another important innovation, the invention developed, that is in 1957, that is Rosenblatt invented the first perceptron. Okay, the perceptron is a neural network model. That is a linear model. That is a neural network model. So then till now we don't know what is neural network, I think, but neural network is a processing element. Okay, so then which will process the input the data, okay, and give the decision. So intelligently give the decision. So then that neural network model first started means in 1957 the perceptron model came. Okay, in 1959 John McCarthy invented Lisp programming language. You know that for artificial intelligence, the first language was used, that is called the Lisp, that is the fourth generation language. Directly ask the question and the system will solve it. Okay, in 1960, Bernard Woodrow, and Ted Huff. So proposed the first layer neural network, that is Adaline. So Adaline is what? That is the different. That is a similar structure of perceptron, but it is little bit different. That I will tell you later on. So then multi-layer unit known as the Madalin. The Adalin is a single layer. Then another version is multi-layer, means adaptive linear neural network, that is called linear elements, that is called Madalin. So then that was developed in 1960. Okay. So similarly, then in 1962, David Harbel and Thorsten Wessel proposed the use of neural network for computer vision. So then he used the neural networks for computer vision in 1962. So in computer vision means what? So then it is used for analyzing not only the one dimensional data, two dimensional, it can also analyze the video data, or it can analyze the behavior, and as well as the expression of human being, everything. So then that are nothing but the computer vision. So then in 1964, the National Research Council, NRC, at USA first made the committee for research in the field of NLP. So then in 1964 onwards, the NLP started. Okay, in 1969, then Marvin Minsky and Swimmer Papert, Minsky and Papert published a paper and mentioned that the perceptron is only be used for classification of linearly separable data. That means the data are placed in a different distribution form. Okay, so then if we can separate them by using a straight line, then it is called linearly separable. Okay, then if we cannot separate the data by using a straight line, that by using a straight line means if you draw a straight line between the two groups of data, suppose two groups means you can say one group is a set of objects of a similar type, another group is there set of objects of dissimilar type. Okay, suppose two groups are there. So by using a straight line, so then we can separate the two data. If it is possible, then it is called linearly separable. So then when they developed perceptron by the Rumelhart, then he told that it is used for solving the linearly separable data as well as non-linearly separable data. But that Minsky and Papert, then they mathematically proved that perceptron can be used for classification of only linearly separable data, cannot be used for non-linearly separable data. So then from that day, the research of the neural network little bit stopped, because then if the perceptron cannot be used for non-linearly separable data, then what to do next? So then no one can design any other model then which can separate the non-linearly separable data. So then that's why during the 1976 to 79, there was no development of what we can say the neural network. Then the research was gone in another direction. That means the knowledge-based expert system. That means they developed different rules to take a decision. Okay, so then whatever the things you have already studied, then that is artificial intelligence part, then that use the number of rules to solve the particular problem. So then that is called the expert systems. And then in 1986, again the neural network breakthrough come. So then the David E. Rumelhart, okay, you should know the name of these three persons. They are dedicated. They have given their entire life for this great research. That is David E. Rumelhart and Jeffrey E. Hinton and Ronald Williams. Okay, so then these three persons developed a algorithm that is called popular algorithm, that is backpropagation algorithm for feed-forward multi-layer neural network. Okay, so then that is used for the multi-layer perceptron. Then what I told that from the beginning, that Minsky and Papert both told that perceptron is a single layer neural network. So then the perceptron can be only used for linearly separable problem, linearly separable data, which cannot be used for non-linearly separable data. But after that, the research of neural network end. So then in that direction, that means the forward, means the feed-forward neural network direction. So then again, these three persons, Rumelhart, Hinton, and Williams, they proposed a very popular algorithm, backpropagation algorithm for the multi-layer perceptron. Then multi-layer perceptron can solve the non-linearly separable problems. From that day onwards, the artificial intelligence came to a new direction, and many research in the direction of neural network started. Again it started. So then in 1987, so then Sejnowski developed the ANN-based speech recognition system in 1987. In 1989, again they developed another person, Dean Pomerlewy, proposed the ALVINN. ALVI means automated land vehicle in the neural network. So in a neural network, that means then they developed a model which can automatically run the vehicles. So then they contains the three-layered neural network designed for the task of road following. That means it will follow the roads, okay, and it will move according to the road size. So then in 1997, another important development happened, that is Deep Blue. So Deep Blue is a chess game developed by the IBM, and that game defeated the world chess champion Garry Kasparov. Okay, in 1997. That was the great achievement of the artificial intelligence. Then was there. So then since the start of the 21st century, many companies are adopting the projects using machine learning with the concept that the machine learning will capable entire market. Machine learning can capture the entire market, because nowadays whatever the electronics gadget we are using, most of our machine learning control. What Alexa you are using, that is machine learning based. What Google using for the recognizing the spam mail, not a spam mail, so that is also there. In Google also they are using artificial intelligence. Facebook also using artificial intelligence, machine learning for recognizing the different objects or faces. Okay, so then Amazon is also using the machine learning for his business. Okay, so then many big companies are nowadays using machine learning to solve the problem automatically without the intervention of the the end user, with intelligently solve the problems. So many advancement of neural network means that is the feed-forward neural network taken place from 2012 onwards. That is called deep learning era started. Okay, so then Google Brain is a deep neural network created by Jeff Dean of Google. So Google first created the Google Brain, then focused on pattern detection in images and videos. Okay, so then it will detect the different objects from the images and videos. So then in the same year, and the ResNet, that is the first deep learning network model. So then won the the ImageNet competition. There is always in every year the competition is going on for, that means a huge amount of image, means 60,000, more than that number of images are there. in images contain different objects, cat, dog, cycle, any ball, any type of objects are there in the image. So then by using this AlexNet, that is the extension of neural network, feed-forward neural network, that can recognize the different objects. So what is the difference between the conventional neural network and that is the means the what we can say the multi-layer perceptron and the AlexNet network. So then all the deep learning are the extension of the artificial intelligence, or we can say that the neural network are the extension of neural network. So in case of multi-layer perceptron, so we can go for one layer, one input layer, then another layer is hidden layer, then another layer is output layer. Because this hidden layer is used to classify the non-linearly separable data. Okay, so if you not use the hidden layer, so this will be just like simple perceptron. The perceptron is a single layer perceptron, that is single layer neural network, which cannot classify the non-linearly separable data. So then we have to use the hidden layer. Hidden layer contains number of neurons in between the input layer and output layer. So then in multi-layer perceptron, we generally use the one hidden layer, two hidden layer, or maximum three hidden layer. Because if you use more number of hidden layer, definitely the accuracy will the performance of recognizing the object or anything will increase. But the problem is that it requires a huge amount of processing resources. That means the memory is necessary, as well as it requires the huge time for execution of the program. It will increase number of hidden layer more than the three hidden layers onwards. That means 3, 4, 5, 6 or more in there. So then when the AlexNet came, so it has 16 layers in between the input and output layers. So then you have to imagine then how much time required for the execution, training as well as execution of the algorithm. So then that's why they use the concept that is GPU. Okay, but then GPU is what the graphics processing unit. So then this unit are used each operation, that means the multiplication, addition of operation can consider as a graphically, and it will process it in a faster way. So then that is the means something about the GPU is used instead of CPU. Okay, so in GPU has more number of cores than the CPU, so its capacity is more faster than the CPU. That's why the GPU came to picture in 2012. In 2014, again the another concept came, the deep face. So deep face is another CNN network, or we can say the deep learning network. So then they used the they developed by the Facebook. So Facebook first developed the deep face, it means deep learning. So then next is the deep mind. So it is again developed by the Google. It contains huge number of hidden layers again. So then it can solve the different types of games, difficult games also. Okay. So then Amazon also developed its deep learning model. So then Amazon machine learning platform in 2015. So used for different service of Amazon. So then another is the ResNet. So ResNet was a CNN model which is used same purpose like AlexNet, but it has more number of hidden layers than AlexNet. So then accuracy of this image computation, that is ImageNet computation, that is more than the AlexNet. So that's why ResNet is very popular nowadays also. Okay, so then that is UNet. Then again Google in 2016 developed another concept, that is tensor processing unit. Okay, so in tensor processing unit, that initial first we in conventional computer we use CPU. So by using the CPU, so we consider, suppose we have a vector, we represent the object in computer in the form of vectors. Okay, so then that vectors has number of components. So that means the coordinates, okay, the x coordinate, y coordinate, z coordinate, like that, n dimensional suppose vector. So then n coordinates are there. So then whenever we perform any type of addition, subtraction, addition, multiplication operations, so at that time what we do? So then by using the conventional CPU, so element wise operation we perform. Okay, so that's why that means that CPU is a little bit slower. So when the GPU concept came, then what happened? That entire vector means vector can be used for mathematical operation like addition and multiplication directly. So that means because of multiple cores are present, so then all the elements, all the coordinates of the vector are simultaneously, parallelly, they perform the multiplication as well as the addition operation. That's why it was faster. Then the tensor processing unit came by the Google in 2016. In TPU, what happened? That it directly consider, instead of single vector, it considers the matrix. Okay, direct matrix operation takes place, so that's why it will become more faster. So nowadays also TPU chips are designed accelerating the computational. Told that neural networks nowadays we are telling that is the extension of neural network is deep learning. Okay, extension of neural network is deep learning, and deep learning contains huge number of hidden layers like then the conventional, that is the feed forward neural network, that is a multi-layer feed forward network. So then as the many number of hidden layers are there, many mathematical operations means are performed like vector addition, multiplication as well as. So to make the means processing faster, so then instead of CPU, we use GPU. Nowadays, Google developed the chip like a TPU. So then we can use the TPU for the further faster operations. Okay. So nowadays also deep learning is not slower. So then we can conventionally we can use in our normal desktop also, desktop or laptop also. So then Intel developed the concept that is Nirvana neural network in 2017. So in 2017, the Nirvana neural network came. So the Nirvana means what here? He took the concept like he embedded the GPU part inside the CPU. Okay, make that make CPU and GPU combinedly form, and they are performing same speed like that GPU also. So then when this is successfully come to the market, so definitely we will our processing will be much more faster. So then I have told you that from the beginning that the problem solvings by using the conventional computer, that so then we must have the algorithm first. So even though even though we have the algorithm, but if we cannot solve in polynomial time, that is also a problem. So then to avoid that, we generally use that artificial intelligence. So then to solve that type of problem in which algorithm cannot be formed or mathematically cannot be transformed, real world problem mathematically cannot be transformed, that thing can be solved by using the artificial intelligence. All the means problems which cannot be solved means in a polynomial time, that means NP-hard problems, traveling self-time problem. Okay, so then these are all means require huge time. So then for that purpose, we are using artificial intelligence. Okay, so but in artificial intelligence, how they solve? They use the all they actually mimics all the means how the living being in this world solve the problems naturally, okay, by their intelligence. The same thing is mimics in artificial intelligence. But in machine learning, specifically, machine learning is another means subset, another subsection of the artificial intelligence. If you say that the artificial intelligence is a set, the machine learning is just a subset of that, and which mimics the intelligence of human being. okay, to solve the problem, not any other animals. Only they solve the problem using the how by mimicking the intelligence of human being. Okay, so then that is called machine learning. So in that way, we can say it is different from the artificial intelligence. Okay. So machine learning is a branch of artificial intelligence that provides computer the ability to automatically learn and improve from the experience. So then main importance of machine learning is here. How it is different from artificial intelligence? I told that it mimics only human intelligence. Okay. So then in case of a human being, to solve the problems, so we must have the knowledge of that. Okay. So then how we are collecting the knowledge? We first learning different sources. We learn the problems from different sources. Then we create, we get the knowledge, and by using that knowledge, we solve the problem. Generally, we do like this way. So similarly, the machine learning means what? It will start learning the data. Okay, so data is learned by the machine and extract the information or knowledge from this data, and by using that it can take the decision. Okay, so that's why it is mimicking the human being intelligence things. So then that's why we say that machine learning. Machine learning, again, two terms, that machine is a device or system or something which is made by the human being, and that is our normal computer or the laptop, desktop, anything. So then learning means what? So then we will write a algorithm. Okay, we will design a algorithm that will learn the means information or knowledge from the data, and will take the decision. So initially, suppose the decision may be correct or may be wrong. So if the decision is wrong, so then that experience machine will store in the means memory, and when next time it will solve the problem, so again use that means data, that where the machine has made wrong. Okay, so then they will add this data, add with the data, and improve the performance. That means as long as the machine will solve the problems, so then the chances of committing error is less than the previous, because it will save the experience. That means the when there is a wrong in the result or decision, so it will save that data, and next time it will not make any means incorrect. So then it will make it perfectly correct. So then that's why it will improve the performance. So that's why machine learning is designing it is also algorithm that allows computer to learn from the data and experience. So machine learning is a data-driven model to derive rules from the data. So then I have told that, so in case of artificial intelligence, so we generally use a set of rules to perform any type of intelligence operation or perform some game application. But in case of machine learning, so we need a set of data. Okay, so before performing any machine learning application, so we need what? The set of data. So then this data will apply to the algorithm. Then algorithm will learn. So for learning, we will write another program. So then algorithm will take the data and execute that, and it will extract the knowledge from the data or relationship among the data. Okay, and by using that, it is derive the rules from the data, and it can intelligently take the decision. So that is the concept of machine learning. So machine learning allows computer programs to automatically improve the performance from the experience. So then from this you may clear that machine learning versus traditional programming. Okay. So in case of sorry. So then in traditional programming, so what generally we do, so we first transform our real life program to a mathematical model, that is algorithm, and we'll write a program for that algorithm, and we use that along with the when we execute the program, and finally we'll get the output. Okay, that is the traditional approach of solving problem. But in case of machine learning, what I told from the beginning, that so here we will not write any program. We will not write any program. What we will give the data, and this is output means what? That is the previous means the previous output. That is the experience. Okay, previous output. So then data means the current data with the previous output. If the output is in previous case, if the output is not correct, then that data is also added with the experience to the along with the data to means produce the set of rules. Okay, the rules are automatically generated by the machine learning concept. So then here we can we it is not necessary to generate the rule by the human being. So automatically the machine will generate the rules when it will accept the data. Okay, so from the data it will generate the rules, and that is considered as a program. So then by these rules helps to take the decision intelligently. So that is the means difference between the conventional computer and machine learning concept. So AI and machine learning. So AI is not a system, but it can be implemented on system to make system intelligent. Okay. So then this is a means AI is not a system. We can say it is a concept. Okay. So it can means it can mimics the or it can follow the means intelligence from different living being. Okay. Machine learning is a system based on the means it extract knowledge from the data sets. Okay, so that is the difference. Then AI is a decision making process. ML means machine learning is used in learning from experience. So AI leads wisdom or intelligence. That means AI, by using the rule, it will use the means wisdom or intelligence. The machine learning leads to knowledge or experience. So AI comprises set of rules which derived based on the data means derived based on the parameters estimated by the means machine learning. Okay, so then what are the parameters or what are the program will generate or the set of rules we generate? We use that rules means in the AI machine, then it can perform the operations. Just a minute. So then next part is what? What happened? Arre, just a minute. Okay. So then next is what that how means machine learning and artificial intelligence, machine learning and deep learning, they are different. Okay. Till now, any doubt you have? Hello.
No, sir.
No doubt, sir.
No
No,
doubt.
sir.
Okay. Okay. Okay, thank you, thank you. So then next part is what again the very popular jargons we have to know that machine learning and artificial intelligence, machine learning and deep learning, how they are different. Okay, so then I have told that the artificial intelligence mimic the means the problem solving capability from the living being, from any living being, not only human being only, any living being. So natural intelligence can be used to solve the problems. Okay, so that's why it is the superset, we can say. So it can mimic the any living being means intelligence technique. So then, but machine learning mimics the process of problem solving by human intelligence. That means machine learning is only mimics the human intelligence technique. Okay, so then learning algorithm with data can improve the performance of the machine. Okay, so the machine learning needs data. From the data, it will get the it will generate the means set of rules or the model set of rules also we can say. Then we can say model or mathematical model we can say. So so that helps us to take the decision. Okay, so then another term is there that is called the deep learning. So I told that in machine learning, one of the important or popular method or the means model is neural network model. Okay, so in machine learning, the main part means important model is neural network model. In neural network model, if you make any extension of that, that means by increasing the number of layers within the input and output layer, that means the hidden layers. By increasing the number of hidden layers in the normal neural network, then we form the deep learning. Okay, that is the extension of machine learning. That is called deep learning. So that's why deep learning is a subset of the machine learning. So in that way, we can say the AI is the superset. The everything what is coming under means all type of intelligence. Okay, operation we are performing, they are belongs to AI. So nowadays we are telling that is AI based system. Okay, so then inside that, the what we are using, either machine learning we are using, or we are deep learning we are using, or any statistical method also we are using. All the statistical methods are coming under the that is called the machine learning also, because statistics is come when the data is there. Okay, so then in machine learning we use the data and perform different statistical operation and also generate the set of rules. Okay, so then some statistical methods are there, some neural network by mimicking the human intelligence means the neural network model is there. So then they combinedly they form the machine learning. And similarly, deep learning is just the extension of neural network parts, not nothing else. So then you just see, suppose how the machine actually means consider about the inputs data what we are giving. So then here I want to say one thing, that here data means what? Data means you can say that means yeah, audio voice is a data. Okay, your fingerprint is a data, face is a data, or we can say that any object like apple, banana, or anything, any object is data. So everything is a data. So then if mathematically we express, the data are one dimensional, two dimensional, three dimensional, or multi-dimensional. Okay, so then in case of one dimensional data is what? Sound is a voice is a one dimensional data. Then two dimensional data is what? Is the images. Images are the two dimensional data. Similarly, we can say the video. Video is that means the spatial means the like image and number of frames. Each frame is an image. So the number of frame collectively form the video. The video is a three-dimensional data. So then like that, so then we represent the data in the form of one dimension, two dimension, or three dimension, or multi-dimensions like this. Okay. So then suppose that we say that a particular object, like suppose this image, that you can see this image. So then this is a two-dimensional data. So each image is a point in the space. Each image is a point in the space. So then how to represent this point in the space as a vector? So that means if it has the number of pixels are, suppose this is a 10 cross 10 matrix, the number of, suppose let's say it is a 10 number of rows and 10 number of columns are there. So then we can say that it has the 10 into 10, the 100 pixels are there in this image. How many number of pixels are there? 100. Suppose 100 number of pixels are there, because we are assuming that 10 rows are there, 10 columns are there. So then total number of pixels are nothing but the 100. That means image is represented as a matrix inside the memory. Okay, inside the memory, the image is represented as matrix. So 100 means 10 row, 10 column. The number of elements of the matrix is 100. So this if in machine learning, I have told that the input to the machine learning is a vector. Input to the machine learning is a vector. So that this matrix will be converted to a vector form. That is, all the columns are considered as a means in a column, first column you keep suppose 10 number of columns. Then for the second row again keep 10 number of columns, like that. So we have the 100 elements vector for this particular image. So then we represent the image in the visual form, a human being. Okay, it will consider, it will receive the image in the form of visual form by our eyes. But machine consider the image are in the form of matrix. Okay, and we give that matrix as an input to the when we give the matrix as an input to the machine learning, then we'll consider as a vector. Okay, so then you just see this image is considered as number of vectors inside the machine. Okay, machine consider as a numerical data, not as the image form. Okay, everything is considered, every type of object, it may be 1D, 2D, 3D, or any ND. So then all represent the object in the form of the numerical value. Okay, so then that you have to remember, machine understand the object in terms of numerical value, but human being understand the object in terms of visual means image form. Okay, so then that is the difference. So then second thing is, if suppose the particular object is represented by suppose two coordinates. Okay, two coordinates means one is x value, another is y value.
Okay, bye. நான் கிளாஸ் முடிச்சிட்டு கூப்பிடுறேன்.
Please mute
கிளாஸ்
your
முடிச்சிட்டு கூப்பிடுறேன். சரிப்பா.
excuse me ma'am, mute your voice, means mute your mic ma'am. Thank you. So then what we are telling, suppose a particular human being, you consider the particular human being, and I want to give that human being as an input to a machine. Then how will you give it? So then what we can consider? We can consider some features. The features are like, suppose height is a feature and weight is a feature. So then by using, suppose from the initially we consider the height and weight are the two features are used to recognize a particular person. So then we can say that this by using a height and weight, we represent that particular object or human being as a point in the space. Okay, this point in 2D space, because the height is one first x axis and weight is y axis. So then it is a point in 2D space. So then if you add another feature to represent that human being, suppose height, weight, suppose color, different is color, next is color. So then it has three features to represent the human object. So it represent a point in 3D. That remember that. Similarly, you just see these are the characters. Okay, means letters, means 0, 1, 2, 3, all these letters are there. So then our machine will recognize, suppose what is 2, this 2, number 2. So then we have some machine learning algorithm will use that and to recognize the object like 2. So it may be in different forms. We may not understand sometimes, but machine will. Sometimes it makes correct and sometimes it makes also wrong, but that depends upon the our learning, means how much machine has learned. If the learning is perfect, so it will give the better result. Okay, that's what I told about that machine learning. Important thing in case of machine learning, the important thing is data set. So then we have to first keep the data set available for performing any type of machine learning means operations or execution of machine learning programs. So then this data set contains what? All the columns data set are represented in the form of matrix. First you remember this. The data set is represented in the form of matrix. Okay. So then each row of the matrix represent one sample. That means the first row is a sample. Sample means it is an object. It is a object. Second row is a sample as an object. Third row is a sample, like that. Suppose there are n number of samples are there. So then each row is a sample. Similarly, each column is a one feature of that particular sample. Okay. So then this is a first feature of this is a suppose date is a suppose a feature. So then this is a feature of the first sample. This is a feature of the second sample. This is a feature of third sample. Like this, it means sorry, this is a feature, second feature of the first sample, third feature of the first sample, fourth feature. Like this, all the columns represent the features of each samples. Okay, and each row is a sample. So like this. So then suppose it has how many rows are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So then 13 number of samples are there, and each sample is represented by using 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 features are there. So then means 13 into cross 9. This many numbers of means elements are present in the matrix. And order of the matrix is what? 13 cross 9. So then 13 samples are there, and each sample is represented by using the means 9 features. Okay, let's we'll discuss about the what is learning. So learning is very important part in machine learning. Already I have told, that's why the name is given machine learning. So learning is a process by which a system improves its performance from experience. Okay, that means first of all, learning means it will process the data and extract the information or extract the knowledge out of this data, or the relationship between the data will be extracted. Okay, so that means information or that knowledge are what we can say it is the mathematical model for the machine learning, and then you will give the input, the machine learning will give the decision. So then when this mathematical model is created, or when this set of rules generated at the time of learning. So when the machine will learn, so from the data, it will create the rules or it will generate the models. And that phase is called training. That phase is called training. Okay, so then we'll discuss later on what is training and testing. But right now, learning is a process by which system improves its performance from experience. But also we are also doing the same thing. Suppose we want to we want to do something of a particular task. So at that time, we must have the knowledge of the about that task. Then only we can solve. Similarly, machine also first learn the means data, then it will take the decision. So then the main person who gave the name machine learning, that is the Arthur Lee Samuel. So then Samuel coined the term machine learning in 1959. Okay, so machine learning is a category of an algorithm that enables the computers to learn from data and even improve explicitly programmed. Then we have not written any program. We have not written any program. So just we will write a program for learning the data. Okay, so then we will not write the program for taking the decision. We will write the program for learning from the data. So then that is learning program we will write. So then we will not write any program to take decision intelligently. Okay, so then that's why I told from the beginning, conventional computer, we need data as well as program. But in this case, in machine learning, we will give the data and learning algorithm or learning program. So that will take the data and process it and generate the set of rules or models for the system, for the machine learning, for the machine. Then machine can take the decision. That is nothing but what the machine learning is. So machine learning can be classified, means learning. The learning can be classified into 3 types. One is supervised learning, that is mimicking child learning from the parents or teacher. Okay, so then that is one is supervised, another is unsupervised learning, and next is the reinforcement learning. So then what is supervised learning? That means when we get back and when we are in a child stage, so at that time our parents, okay, teach us that you just see, this is a mango, this is a banana, this is an apple. That means they are showing us different shapes. Okay, and then our brain start learning. Okay, similarly also the character, that is A, B, C, or 1, 2, 3 numbers. So then they will initially show us the different numbers or different characters. Then after that we analyze inside our brain that this type of object is A, this type of object is B, or this type of shape is apple, banana. Like that we will save in our memory. Okay, and then the person will ask us, then our parent will ask, what is this this is then the immediately baby is saying that this is a banana, this is apple, like that. That means what? Initially, the means the parent teach the child that the different types of object. Then it will ask the child that it tell me what kind of object is this. So then if it will say correctly, then you will say okay, yes. If it is wrong, so then baby again start keeping that object in his or her mind that this is an apple, not orange. So like that, it will save it in your mind. In future, if whenever you will ask, then it will improve its performance. That means it will understand that this is an apple, not that is orange. So that like that, so it will improve its performance by using gradual from the experience. So same machine learning also perform the operations. Okay, so that means the supervised learning, in one word we can say, then learning with teacher. That means the teacher is available to teach initially to learn the machine, then machine can take the decision next onwards. Then another is what? Unsupervised learning. So in case of unsupervised learning, so then mimicking human learning based on some similar and different objects. That means what? Suppose then here teacher is not present. Okay, so supervisor is not present. So then you means automatically learn from different shapes. Okay, as the shape is given, right? You understood? So then as the different shape is given, so then you can say that okay, the shape of apple is just like this and shape of orange is different. So then these two are the different object. So then you can recognize it from their shape. Similarly, that means without any supervisor or without any teacher or without any helping hand, you can understand the object. Similarly, machine can also understand without telling that this is an apple or this is an orange or this is a banana. So machine can understand by the different shapes. Okay, so that is called unsupervised. Unsupervised means the supervisor is not available, teacher is not available. That means learning without a teacher. Supervised means learning with a teacher. So then unsupervised means learning without a teacher. So then next type of learning is reinforcement learning. So here means both things are performed. That means mimicking human learning based on reward or punishment given by the environment. That means if suppose you will ask the child, means after learning, if you ask the child, you tell me what is this object, then if he or she can reply the answer correctly, then you are giving reward. Okay, you will get a chocolate. Then the child understand that he has told the correct answer. But if there is a wrong, so then you will give some punishment, okay, by slapping the means one slap. So then that is called that baby understand that he has done a mistake. So then it will consider as an experience, and in the next time it will not make the mistake. So then that's why it is means from that feedback, feedback in the form of reward or punishment, the machine can understand then whether it is correctly taking the decision or incorrectly taking the decision. In that way, it improves the performance. I told always that when if it is giving correct result, fine, it is fine. If it is not giving correct result, that means data is again considered as an input to improve its performance. So machine learning is a process by which system improve its performance from the experience. So then I can give one example, like in Google. In Google, when the NLP started, that means if you speak something in Google Talk, so then it will perform some operation. So initially, when this software developed, so at that time, if you speak, so then it cannot understand your language. Right now, gradually after improvement, number of improvement, so then right now it can understand the language immediately without making much more mistakes. So then that's why that means it will as the experience, it will get the experience, so it will improve its performance. So then there are three types of learnings are there. And I can give the example, very rough example. In supervised learning means what? That means you are telling the person to solve the example problems of the book. In the book, the example problems are given or the exercise problems are given. You solve it and check whether the answer is correct or not. Okay, first you solve some example problems. In the book, some example problems are there. Then after that, exercise problems are there. Okay, so in the exercise problem, answer is given some part of the book. So then first you solve some means example problems. Then that is learning process is over. Then after that, a problem is given to you and you solve it and you check the answer. If the answer is correct, that means your decision is correct. If the answer is not correct, that means you are committed a mistake. So then that is called what? Supervised learning. So whenever you are giving exam, at that time the question paper is given. Only question paper is given, answer is not given. So then you solve the problem by yourself without the help of any supervisor. That is unsupervised learning. Hello. Any doubt till now?
Yes, sir, we are listening.
Yes, sir. Anything you want to ask or
No,
continue?
sir.
Continue. I should continue. Yeah. Okay. Okay. So then, there is a comparison I have made, the supervised versus unsupervised. So in case of supervised, you just see the data is given corresponding the class index or class labels are given. Okay, this data or these samples belongs to which class is given. Okay, here also the sample is given, and suppose these are the banana and these are the apples, and different class labels are also given. Okay, so then different shapes are given with its class label. So then the machine will perform supervised learning and take the decision. So then the data is labeled with the class or value. So then it performs the operation. Another is unsupervised learning. You just see the data is given, but without the class label. The class labels are not given. The teacher is not present. Okay, here teacher is present. So then by the different shapes, okay, here different colors are there, but suppose different shapes. So then machine can group the different objects. That means the unsupervised operation means is used for application, just like separating the set of objects of similar type from different objects. Okay, so that means it will separate the similar objects from different objects. So then that means it will make a different groups, set of groups in case of unsupervised learning by the shape and the relationship among the data. So then the machine can understand this group of data belongs to which class, this group of data belongs to which class, this group of data belongs to which class. So it will make separate the different groups of data. But in case of supervised learning, what generally happens? So it just maps. It maps the data to its specific class label. Okay, so in case of that supervised learning, what happens? So you will give the data, so then machine will tell this sample belongs to which class. So just you give the sample, it will tell the sample belongs to which class. That is called classification operation. So then the supervised learning is used for classification operation. That means you will give the sample, it will tell us the class label. That is one kind of operation. Another operation of supervised learning is regression. Regression means what? That means you will give the data. Okay, so then it will fit means this data is fit fit in a function. Okay, so that means it will give the real value, not the class label. Okay, so that is called generalization of the classification. Regression is called the generalization of classification. That means in case of classification, you give the sample, it will give us the class label. In case of regression, you just give the data point and it will tell that this point belongs to which which position in the particular function. So that means it will generate a function. Okay, so then by using the data, it will generate a function. That means function means y equal to suppose f of x. That means you give the x as a sample, so it will give the y as a real value of that function. Okay, so that is called the regression. So then by using the supervised learning, we can perform classification as well as regression operation. So the regression operations are used for prediction. That is the share market prediction. Okay, so suppose you have made a website to means that means you will give your old gadget, electronics gadget, and it will ask the computer what should be the cost of that gadget. So that is called that is the prediction. That is the or we can say the whether somebody has paid the income tax or not. The machine learning, by using the neural network or machine learning, we can find out that. So then it will give us whether the person has given the the task or not, how much task he has given. So these are all some real value. Whenever the machine will generate the real value in case of supervised learning, so it is used as a prediction purpose. That is the regression. Okay. So then another is the classification. It will generate the class label. It will just map the input samples to its corresponding class level. So then in case of unsupervised learning, I told it will make a different groups. In case of just unsupervised learning, we can give an example that suppose there is an image. In that image, one object is there. Okay, one image is there. Suppose your photo is there. So in passport photo. So in that, so your shape is there, and in the side the background is there. So we just make a segmentation. Okay, segmentation means what? We'll separate your object from the background. We'll make the background is empty, means black, and only the object is present. Okay, so we'll consider only object part, not the background part. That is called segmentation. And segmentation is one of the example of unsupervised learning. You just remember this. The segmentation is one of the example of unsupervised learning. In case of image processing, I'm telling. So then here also, then what it is doing? So all the pixels which are related to the objects, they will form a group, and all the pixels which are not a part of the image, they are also make another group. So then that is a background group, and another group is the object group. So then we'll consider only object group, not the background group. That is called segmentation. So then image segmentation is the example of unsupervised learning. So then this is the difference between the supervised learning and unsupervised learning. So then many algorithms are present in case of supervised and unsupervised learning. Okay, so then machine learning algorithm, I have shown here two algorithms because in reinforcement learning, that is used for development of robots or games. Generally, we use that kind of application. But in case of supervised and unsupervised learning, we generally use for classification as well as regression, here clustering, and also we use for association in data mining application. That is association. Association means particular, means which are the objects will place together. That means suppose means whenever we are going to a that is mall. So at that time you just see. So where there is a T, there is a bread. That means that they are associated each other. So then we can keep that similar object in one place and this similar object in other places. So then that will generate some rule by using unsupervised learning. That is association is one of the example of unsupervised learning. Another is the clustering. Clustering means here segmentation is also called clustering. Okay. So in case of classification, in case of supervised learning, the classification, then there are many mathematical models are there. One of them is the neural networks. Already I have told about the neural networks. So this is one of the model of machine learning, and all others are also the models of machine learning, different models of machine learning based on statistical model. Okay, statistics, mathematical statistical model. So then these are the support vector machine is a very popular model of supervised learning. And the base classifier is another classification model, and neural means nearest neighbor classifier is another supervised learning and model. So then these are the different supervised model means learning models are there. Similarly, the same can be used for regression also. So whenever we use for regression, little bit difference is there, but same neural network can be used for regression. Same the nearest neighbor classifier can be used for the regression also. Okay, nearest neighbor means regression. Then that is support vector regression. So then these are the different regression techniques are present. It will regression always generate the output in the form of real value. Just remember. And the classification always means represent the output in the form of what? The class index or the class label. That you have to remember. Okay. So then now I have just want to explain the principle of supervised learning, how actually it performs the learning operation. Then after completing this session, at least you can understand that how actually supervised learning works, the principle takes place. So then that we discuss right now. So then till then, any problem, anything you want to ask, any doubt? Hello.
No, sir. No, sir.
Okay. So okay. Thank you, ma'am. Thank you. Thank you. So then here that I told that for any type of machine learning, we need the data set. Okay. So then these are the first is the input data set. We have to consider here the training means the data. Okay. The data is given here. Just to see that these are the test data or test document or with image, video, anything you can consider, or voice also. Then anything, any object can be represented in the form of vectors, and that is nothing but the objects that we can say. So then these objects are represented with the help of some feature vector. Okay, vector means here vector has number of coordinates. Each coordinates is a feature in machine learning. So then this each vector is called a feature vector in case of machine learning. You have to remember this. So then these are the means the data or the samples of different samples of different class. So then these samples are represented as a feature vector in case of machine learning. Okay, that is the input to the learning algorithm, machine learning algorithm. Okay, so then these are what the class label, because in supervised learning I already told that you have to given the object with its class label. Class label means suppose the objects are apple, a banana, or cat, dog, any type of objects are there corresponding this particular sample or dog sample, you have to give the class label as a dog. Okay, particular cat sample, you have to give the class label as a cat. So then different labels are there, and the data is given. So then only we can say that it is supervised. That means these are the guide, or these are the supervisor, or these are the teachers. Okay, that helps the machine to say initially at the time of learning. At the time of learning, the machine is said that these images are of what kind of types. So then after learning process is over, just remember this, after the learning process is over, next onwards, we will not give any type of means data for next on learning. So it only we can perform what? We'll evaluate the performance. So then we'll evaluate the performance by giving some test data. Data means that data are not used in the time for training. So in the training time, we are giving different types of dogs, okay, or different types of cats, different shapes. In the testing time, we will give a new types of dog and new types of cat images. So then to check whether our machine can recognize that whether that particular image is a dog or particular image is a cat, even though same type of dog or cat we have not given. That I have told in the beginning that suppose the letters 1, 2, 3, 4, 5 letters are there, but the two we have given some data, some different kind of one, some different kind of two shape. But sometimes after learning, whenever we are asking to the machine, we are giving different type of different shapes of 1, 2, 3 data. So that is called the test data. Okay, test data is unseen data during the training. During the training, this data is not given. So during the testing, we are giving that. So then that's why if the machine can recognize that object, then we can say our learning is perfect by the machine. Then our model is very means optimal model, which gives the better result, and we can use for different application. Okay, so then we can say that any type of voice recognition, suppose you just tell your name, then machine will say, okay, you are this person. Okay, so then that is why voice recognition is also possible. Then face recognition, that means you just show your face, machine will tell you that okay, this is the person. So then these are called what? The supervised learning. Before that, some data already, suppose in your office, in your institution. So whenever you are, nowadays biometric systems are used for attendance. Okay. So then whenever we are entering, whenever at the first time when the system is deployed, that means the fingerprint system or any kind of biometric system. So then first what you have to do? So you have to give your fingerprints. Okay, number of fingerprints, 1, 2, 3, 4, number of fingerprints you have to give, and in different order. Okay, so then that will save in the memory. For what purpose? For the training purpose. So once the training is over, that means that training data. Okay, so then that data are stored in the memory. Okay, like that that is called template. Okay, that template are stored in the memory. So then after learning, that is means received. So then after that, whenever you will give your fingerprint, then that fingerprint again means converted to the feature form, then it will match with the stored data. Okay, so if it is matched, that means you are the legal person, you are the valid employee of that institution. Otherwise, it will not consider. So then, or your attendance will be considered, or otherwise your attendance will not be considered. So then that means, so initially the learning takes place, then after that the testing phase is going on. So then this is nothing but the supervised learning, the testing time. So then both are different. They are two different phases. So then supervised learning has two phases. One is training phase, another is testing phase. In the training phase, learning is performed. In the testing phase, the system performance is evaluated. Okay. So then that is nothing but the supervised learning concept. The next part is what? The just a minute.
Excuse me, sir.
Yes, yes.
Sir, this is Chandramouli. If you
Yeah.
can conclude it in 5-10 minutes, so that would be better, because they have two more sessions in the afternoon that starts at 2 o'clock. So sorry
Okay,
to.
sir, only 10 minutes is sufficient. Give me just I copy.
Yes, sir. Thank you.
Okay, sir. Okay. So then already I have told that supervised learning means the data set is divided into two parts. One part is the means same one complete data set is divided into two parts. Some parts are used for the training purpose, and rest of the part used for the testing purpose. So then I told that the test data are the unseen data. That means at the time of learning it is not given. So then they are different. So then we perform the means we evaluate the performance at the time of testing. At the time of training, the machine learn the data and means evaluate the performance at the testing time. So then this is nothing but what the training time, and that is the data. Then how we divide the data set? The data set is divided into two parts. One is training set and test set. So then different methods are there. Suppose we have a data set which contains suppose means two class problem. 100 data is there. 50 data from one class, another 50 data from the next class. So then we will consider that suppose how much percentage of training data is required from each class. Okay, say similar means balance means class samples we will consider. That means suppose we will consider 50% data or 60% data suppose for the training, and the 40% data is testing. So then this is not any mandatory rule. So that is a thumb rule, like so that you can change the number of training size as well as number of the test size. That depends upon the performance of the machine. That if your machine can perform well with 50% data, so then don't give the 60% data. So first we try with 50%. If the performance, suppose you are getting 90% accuracy, so then don't give the 60%. Then you give the 60% training data and see that what is the test. Then test with the 40% data and see what is the performance. If the performance is 95%, then better you give 60% data for the training and 40% data for the testing. But if you increase that, suppose 70% data for training and then 30% for the testing, and if you see that result is not means the result is more than that, then fine. If it is less than that, so then that means we should keep the training sample is 60%, not more than that, because if you give more than that, then it will be overtrained. If you means that's why. So then if the system is overtrained, the performance degrades. Okay, so then that's why we have to keep our training means by the trial and error methods, select the number of percentage of training data and percentage of testing data. So then there are different types of distribution of training and testing data, just splitting. One is random sampling, random subsampling, k-fold cross validation, and leave one out cross validation. Just to see the figure, then you can understand. That means random sampling. In the random sampling, first what you will do? First, you perform the data by using perform the experiment by using the experiment one data. That means all the data. Then first you take some data for the testing. Means suppose 40% and the 60% data for the training, and perform randomly select and perform the experiment. See the result. What you are getting. Suppose you want the result. The second is a second experiment. Perform second experiment with the different training and testing data randomly generate. Okay, and third experiment similarly you just perform the operation and see the performance. Suppose E3. So then finally you divide that you add all the performance result by and divided by k, then you will get the average result, and that is the average performance of the system. So then this is one way. Another way is, means what is the problem with that? So that we cannot say that after in the first experiment we have taken randomly the data for the training and testing, and similarly means randomly first take some data, that is 40% for the testing and remaining for the training. But similarly for the experiment 2, similarly for the experiment 3. But we cannot say means in the experiment 2, whatever the data we have kept for the testing, and experiment 1 may not have the same data. It may be same data also. That is the problem. So then to occupy all the data, we generally use, this is the most popular method, that is cross validation, k-fold cross validation. What do we do? In the suppose first experiment, we consider, suppose here 20% data for testing and remaining data for the training. Okay. In the second experiment, the second part means the part of 20% is used for the training and remaining for the testing. Third phase, fourth phase. In this way, all the data can be used for the training as well as for the testing. Okay, so that is give the better result. It will give the means better performance than other means methods. So then we generally use the cross validation method, k-fold cross validation. And k means here, suppose we can k means how many experiments we are performing. K means here total data is divided into suppose 5 groups, and every time each group is a test set, and four are the 4 groups are the training set. Okay, so then how many experiments will conduct? We'll conduct 4 experiments. So in that way, 4 are the different test data and others are the train data. So in this way, all the data are used for the training and testing. So then performance improves. So then another method is what? If the number of data are not very large, so then what we can do? So we can do one, leave one out cross validation. Okay, LOOCV. So then means one leave out validation. That means you just keep one data for the testing and remaining data for the training. Then second data for the testing, remaining data for the training. So like that you go on continue. Suppose 100 data is there. So every time the one data will be test data and others will be the train data for each class. So then this type of generally the leave one out validation are used for means image processing means application in biometrics also. Okay, so then there are different types of methods, and I have told you that that during the learning time the system generates this type of activity, I mean, this type of decision boundary. Okay, above this is these are different one class, and below this is another class. So then these boundary decision lines are generated. This is a what? This is a actually function. This function is the function parameters are evaluated at the time of training. Once the function parameter is evaluated, so then at the time of testing, so then we'll find out the distance. If this distance is above this line, then we say this is a one class, and below this line, we say this is another class. So then this is the nothing but the types. So any questions, sir? Anybody have any question?
No, sir.
No, sir.
No, it is actually very difficult to understand everything in 1 hour or 1.5 hours. But at least
Yes.
the terms are very important. So then if you understand in future, so whenever if you will be interested, then you can also proceed. It is not that that you cannot do, but if you understand the basic, then you can. It will be easy for you to study further. Thank you. Thank you, sir.
Yes, sir. On behalf of the participants and on my own behalf, I really thank you, sir, for giving an overview of machine learning in a very short time.
Yes,
And
sir.
that really is a very great session with covering the major aspects. And I request you to please send your PPT so that I can share with all the teachers so
Sure,
that
sir. Sure.
that will be very helpful for them so that they can
Okay.
once again go back and revise the content.
Okay, sir. Definitely, sir. I will send all my PPT. I will share the PPT to you in your
Yeah.
mail ID, and then you can share to the students also.
Sure, sir. Thank you, sir. Thank you very much once again for such a nice and informative session.
So thank you very much, sir. You also. So then you given me the opportunity. I also extend my gratitude to all the staffs of Computer Science Department of Tamil Nadu University. So then for also the audience, all the participants, they have the patience to listen my session. Thank you very much. All the best for the participants to start with machine learning applications or study with the machine learning. Thank you, sir. Thank you.
And we'll now break for the lunch and we'll be back sharply by 2 o'clock to have this next session.
Okay, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank
I
you,
am
sir.
leaving, sir. I am leaving.
Okay, sir.
Okay, okay.